Hello, boys and girls. Welcome back to another video. Mr. Carmen here.
And Miss Harper.
And today, what are we going to talk about, Miss Harper?
I believe we're talking about area of polygons, Mr. Carmen.
Polygons. So, Miss Harper, what are polygons?
Polygons. Ooh, well, first time I hear poly, I think of a parrot.
Okay, like polygon, pair, like Polly want a cracker, right?
Yes.
Okay, that's a very good educated guess, Harper. Unfortunately, in mathematics, poly means something different.
So it has nothing to do with the parrot?
No,
okay.
Unfortunately not.
Nothing to do.
Even though parrots are very, very lovely, though. But anyway, in mathematics, polygon just means many. So it could be a many, it basically just means a many-sided figure. So it could be triangles or squares or
octagons,
nonagons, dodecagons.
A circle?
Oh, a circle is it's a special type of polygon because it doesn't have any sides or edges.
Right.
So a lot of philosophers call that an infinite polygon.
Okay.
So anyways, we're going to find the areas of these polygons today, like the one you see on your screen right now is a triangle.
Yes, it is.
Okay. So, Ms. Harper, you want to demonstrate this one?
I would love to demonstrate this one. So, looking at the triangle, there's two things we need to recognize. We need to understand what the base is, which the base is the bottom, which would be 11 feet. And we also need to identify the height. And which, remember, the height will always go from the bottom or the base of the triangle to the very tip top. So, the height is 8.4 feet. So, I'm going to represent that with base B equals 11 feet. And my height is 8.4 feet. Now, there's a formula to find the area of a triangle, right, Mr. Carmen?
Yes, there is. So you may recall from last year, your teacher may have shown you a formula to find the inside of the triangle. So the area formula for any triangle is 1/2 times base times height. Or he or she may have told you another variation, which you can also do base times height divided by 2. Either way, because if you divide by 2, it's the same thing as multiplying by 1/2.
Or taking half of something.
Exactly.
So now I'm going to take what I know and plug that into my formula. We don't know the area, so I bring down my A equals 1/2. Always bring down the number that's in your equation. B is my base, which was 11 feet. And my height is 8.4 feet. Okay? So now I'm going to go on to bring down my area. And I also know that I have feet times feet, which is feet squared. And area is always measured in feet squared. So I can go on and bring that down. Now, 1/2 times 11, I know half of 11 is 5.5.
Yeah, or 5.5.
Or 5.5. But I do not know right off the top of my head what 8.4 times 5.5 is. So I'm going to use my handy dandy calculator, Mr. Carmen. And I get 46.2. So the area of that triangle is 46.2 feet squared.
Good. And of course, you're going to notice on your answer choices on here, there's actually 2 answers that say 46.2, right, Ms. Harper?
Yes.
But how do I know which one to click, feet or feet squared?
Well, it's area, and area is always squared.
Exactly. So, I'm just going to click on show answers, but the correct answer on here is 46.2 feet squared.
Woohoo! I got it right.
Good. All right, so now here's the next one. Ooh. Okay. This one, I don't know the shape of this, Miss Harper.
Well, it's a polygon.
It is a polygon, but the thing is that it's not a regular polygon, right?
That is true because it looks like it could have a rectangle in it, but it's not a rectangle. And you could probably make that into a square, but it's not a full square.
Good.
So I guess we have to divide it up, right?
Exactly. So what we're going to do, this is known as an irregular shape. So what we're going to do is that we're going to split this into shapes that I'm already familiar with, like rectangles and squares and triangles, things like that. Okay. So I'm going to go and put this underneath here. So what I went and did while we were talking is I went through and copied this down. We're going to highly suggest you all to do the same as well. So we're going to go through and split this into shapes that we already know. So, Ms. Harper, do you want to do this or me or?
Well, here's the funny thing.
Go ahead. Yeah.
Me and Mr. Carmen, as you've seen in the other videos, we teach differently. We see things differently. And I bet you how would you divide this up, Mr. Carmen?
Okay, so here's what we're going to do. I'm going to work this one out first, and then Harper is going to work out her way. Okay, yeah. So here's the way I look at this. I like to look at this as splitting it like this. That's the way I'm going to split it up. So how I'm going to do this, think of this now as like trying to figure out two areas in one problem. And now I'm just going to add up at the very end to figure out the total. So here I have a 5 by, now here's the thing. I know this side says 12, but where I split it right here, that's not actually going to be 12. I'm looking for this side here. So what this is that I have to take off the 6 feet because I know that this side and this side combined is 12. So 12 minus the 6 feet here would make this one 6 feet. So now I know that 5 times 6, which will be 30 feet squared. All right, and then all there's left to do now is just the bottom rectangle, which is a 16 by 6. Now, the thing is that I don't know that top of my head, but I'm just going to do just a quick side work on here of 16 times 6. 6 times 6 is 36, carry my 3. 6 times 1 is 6, plus 3 is 9. So now I know this bottom part is 96 feet squared. And then the last thing to do, I'm sorry, this keeps on going off the screen. So now the last thing I got to do is just add up the remaining parts, which 30 plus 96, which the grand total area should be 126 feet squared. All right, so now, Ms. Harper, how did you think about that?
Well, I'm going to look up here using the screen. Pen, we'll make it blue. So I kind of divided it right here, actually.
Oh, okay. So let me go and put mine back underneath the camera for reference. So I split mine up from left to right. You went up and down.
I did.
Okay.
So that means that this rectangle right here is a 5 by 12. So when I do 5 times 12, I get 60 feet squared. And then that divided this up. So with all of this being 16 and this being 5, so 16 minus 5 is 11. So this side right here is 11 feet. So the rectangle here is an 11 by 6 feet, and 11 times 6 is 66 feet squared. And then when I added both of those together,
so overall, your final answer on here should be 126 feet squared.
Exactly.
Oh, so click back. Yeah. There you go. Okay. So, all right, we got one more type of problem to show you, and then we're going to tell you about what we're going to be expecting you all to do next, okay? So let's go ahead and erase this work. All right, so here is the last problem. Okay, so now on this problem, we need to go through and find the area of the shaded region. Okay.
So that means we have to find the area of 2 different shapes.
Exactly. So what 2 shapes do you see, Ms. Harper?
I see a square and a triangle.
Good. Now, the thing is that even though it looks like a square, it looks perfectly like a square, would that technically be a square, Ms. Harper?
No.
Why not?
Because even though it looks like a square, when I look at the measurements, I have a 6 and a 5.
And that's the key, is that a square has all equal sides, whereas your length right here is 6, and your width down here is going to be 5.
So it's actually a rectangle instead of a square.
Yeah, technically by definition, it would be a rectangle. Okay, so Ms. Harper is going to work it one way, and then I'm going to work it another way. I'm going to see if we get the same answer.
All right.
Okay, so Ms. Harper, go on and work your way first.
So looking at the rectangle, I have a 6 and a 5, which I know that for a rectangle, the area is length times width. So if I do 5 times 6, I get an area of 30 units squared. Then the triangle, as we talked about earlier, the formula for that is area equals 1/2 base times height. And the area is going to be 1/2. The base is 3, and the height is 3. So I can't tell right off the top of my head what half of 3 is. So if I do 3 times 3, I get 9. And half of 9 is 4.5 units squared.
And Ms. Harper, normally every time we do math, we always have to go from left to right, correct?
True.
So why could we reverse the order on that one?
Well, that's because of the commutative property.
Oh, okay.
Which means that no matter what order you put it in, it's going to be the same answer. Kind of like what we just did with the previous polygon. It didn't matter how we split the shape up. We still got the same answer.
Exactly, because the thing is that all the operations that are happening in that particular step is multiplication.
Exactly. And now I want to find the area of the shaded region. So that doesn't mean I'm adding to it to see how much they are together. It's to see how much they are different. So I need to do 30 minus 4.5. And I know that 30 minus 4 is 26. Minus half of that would be 25.5 units squared.
Good. So of course, the thing is that where I'm seeing this for the first time on here, Miss Harper, the only thing I would just basically do different on here, I would do the exact same work right here, because the main difference between the previous problem and this problem, the last problem, it was a composite. It was a composite shape where we added everything together.
Exactly.
This one, we're looking for just the shaded part right here on the outside of the triangle, but yet inside the rectangle, which is 25.5.
Exactly.
The only thing I would just done extra on here was just put the 0.0 and then borrowed and everything. But I mean, overall, it's still going to be 25.5. You're exactly right.
All right.
Okay. So, Ms. Harper, you have anything else to add before we reveal what to do?
No.
Okay. All right, boys and girls, here's what we're going to be expecting you all to do. Right now, we showed you just a basic 3 problem review over area polygons. What we're going to do on our end is that we're going to make a similar quizzes just like this. It's going to be the same type of problems. It's going to be just different numbers, and we're going to be expecting you all to complete and show your work.
Exactly.
Okay. So until next time, we'll catch you all in the classroom. So see you all.
Bye-bye.